So today we're going to cover 10.1, 10.2, and 10.3. These problems don't take very long to answer, and a lot of this we're going to be able to do in our calculator, okay? I have made a list of the first 15, what we call perfect square numbers, okay? The perfect squares are the answers to these multiplication problems, okay? Like 49 is considered a perfect square because there's a number times itself that gets you 49, which is 7. So 7 would be the square root of 49. And that goes along with all of these. Like the square root of 225 would be 15. Okay, so let's start looking at these in 10.1. These are called radicals. Anything that has a symbol that looks like this, that is called a radical symbol. The most common one that we see is the square root, okay? The square root looks like this. It doesn't have a little number in here. Any other roots, like the cube root, you'll see the number in here, okay? So when you're talking about the square root, whatever is underneath here, like on number 1 is 49. When you're taking the square root of a number, you're asking yourself, what is the number times itself 2 times that gives you 49? So that's why I went ahead and just made that list at the beginning so that you'll just have that handy. Okay, that's going to make this section go a lot smoother. So the square root of 49 would just be plain 7. Okay, we'll get to these in a little bit. Okay, but if you're taking the cube root of a number, you're trying to find what number that multiplied by itself 2 times gives you this, but what number multiplied by itself 3 times gives you this. And in this one would actually be 2, right? Because 2 times 2 times 2 gives you 8. Okay, so that's what a cube root is, but we'll talk about those later. Okay. The first several problems are just going to be doing square roots. So that was number 1. Number 2 says find the square root of 36. In other words, what number times itself 2 times is 36, which would just be 6. Number 3, square root of 81. So what times itself is 81, which would be 9. Okay, so there's the first 3. Now let's look at number 4. You have the negative, but it's on the outside. And then you have the square root of 1. Anytime you have a negative, but it's on the outside of the square root, it doesn't really affect what's going on inside here. This negative on the outside will just come down. In other words, that's saying, what is the negative, or what is the opposite of the square root of 1? Okay, the square root of 1, what times itself is 1, which is 1. So the negative of the square root of 1 is 1. Okay, let's look at number 5. Number 5 has a negative on the outside. The square root of 289. So, the list had to stop somewhere. The highest perfect square that was on the list was 15, right? 15 times 15 was 25, okay? But the list actually goes on forever, okay? So let's look at how, if it's not in our list, what we would do on our calculator to find the negative of the square root of 89. So you would just hit your negative button. Now, your square root symbol is this x squared button, but it's blue, right? So to get to any of the blue functions, you have to hit your second button first. So I'm going to hit second, then the square root. That's what gives you your square root symbol. So again, second, square root. Now you can just put whatever you need under there. So in this case, it's 289. Hit enter. So that would tell you negative, right? Because the negative just comes down. And then the square root of 289 was 17. Okay, let's look at number 6. A lot of times fractions make things more difficult. When you're taking a square root of a fraction though, it's almost like it's just two separate problems. You just think of the top and the bottom separately. So in other words, take the square root of the 9. So what times itself is 9, which just gives you 3. And the square root of 16, or what times itself is 16, which is 4. So just do them like separate numbers. So the square root of 9/16 is 3/4. Number 7, excuse me, the negative on the outside. The square root of 81/4 on the inside. So again, the negative just comes down. The square root of 81 is 9. The square root of 4 is 2. So negative 9/2 would be your answer. Okay. Now look at number 8. We have something that we haven't seen before. All the negatives that we've seen so far have been outside the square root. But on number 8, you have the square root of -64. Okay? If your negative is underneath the square root, that's when you are going to answer with this B. The square root is not a real number, okay? Because if you tried to do that in your calculator, so if you hit second square root and then put -64 under there and hit enter, it's going to tell you non-real answer, because there's not a real number that you can multiply times itself and get a negative, right? Because if you multiply the same number together, you're always going to get a positive answer, right? Even a negative times a negative is positive. So that's why this one is not a real number. Same with number 9. I have a negative on the outside, but I also have the negative on the inside. This right here, if you see that, it doesn't matter what's out here. If you have a negative underneath a square root, it is not real. Number 10. Okay, before we do number 10, just like I gave you a list of perfect squares, I'm going to give you a list of perfect cubes also, just to make it easier. So the first perfect cube is 1, right? 1 times itself 3 times is 1. And 8, 27, 64, 125, 216, 343, 512, that one's 729. Yeah. And the last one we'll do is 10, which is 1,000. Okay, so I'll let you get those. So all these numbers that are the answers, those are perfect cubes. So if I'm taking the cube root of any of those, I will get a whole number answer. Like this right here, the cube root of 216. In other words, what number times itself 3 times gives you 216? Well, that would be 6. Okay, I'll give you a few seconds to write that down. Okay, so you have that list of perfect cubes. So now let's use that to help us do the rest of these. So we have the cube root of 27, and that's what a cube root looks like. Is it has, instead of nothing in that little area right here, it's got a 3, which is telling me I need to find the number times itself 3 times, that is 27, which is 3, right? That's how you can just use that list. 3 times itself 3 times is 27. Now, on number 11, we do have a negative underneath. But when you are taking a cube root, it is okay. Because what do you get when you multiply a negative number times itself 3 times? Any negative number. What's negative times negative turns you positive. So now you're positive from these multiplying these two, but what's a positive times a negative? It is going to give you a negative answer. So if you are doing a cube root, it is okay that it's negative underneath. You can get that answer. It's just going to be the negative of that number. So you would just look in your list and see the 729 and see that the cube root of 729 would be 9. So the cube root of negative 729 would just be negative 9. If the negative is on the outside, like number 12, then it's just like a square root. It doesn't affect anything at all that's going on underneath here. That negative just stays on the outside. So I have negative, then the cube root of 8 is 2. So you have negative 2. Okay, number 13. Negative on the outside. So again, that one just comes down, right? It doesn't affect anything that's going on in here. This negative just came down. But what's the cube root of negative 216? So the cube root of 216 is 6, which just means the cube root of negative 216 is negative 6. But what does this mean? That means the opposite or the negative of negative 6. So since there's 2 negatives there, that's what actually would turn that answer to positive 6. Okay? Number 14. I'll put 14 and 15 up here together. All right, when you are taking a root, and what you're taking a root of is raised to that same power as whatever the root is. And remember, the square root, it's kind of like it's just not seen in here, is the second root, right? You're trying to find what number times itself 2 times. So even though you don't see a number, the square root is like it's the second root. Anytime that the power of what is underneath your radical and the root number are the same, it's kind of like they just cancel each other out, and you are just left with what is under there. So that would just be 14. Same thing here. If the power of what is underneath here is the same number as the root, raising something to the 8th power and taking the 8th root of that same thing is just canceling each other out. So you are just left with y. All right, so that was 10-1. Let's look at 10-2. In 10-2, we are looking at numbers that have exponents, but those exponents are fractions. So let's talk about what that means. If your exponent is a fraction, these two things mean the exact same thing. if you're raising a number to an exponent, but that exponent is a fraction, and that top of that fraction is a 1, this number right here tells you what root you're taking of this. The second root is the square root. So that's why the square root of 9 and raising something to the 1/2 power is doing the same thing. You could actually still do this. You can do this in your calculator, right? I know how to go up into an exponent. So you would just type in 9, go up into your exponent. Now, to be safe, the 84, you don't have to put the parentheses around it. I can't remember about the 83. So just to be safe, I'm going to put, since my exponent is a fraction, I'm going to put parentheses around it. So I'll do open 1 divided by 2, close. So I just raised this 9 to the 1/2 power by going up into that exponent and hitting enter. So you can do all of these in your calculator. Okay, like number 2. Oh, this was number 1. 9 to the 1/2 power is exactly what number 1 is. So again, square root, same thing as 1/2 power. Let's look at number 2. We've got 16, but it's to the 1/4 power, not the 1/2 power. So I'm not taking the square root. I'm actually taking the 4th root of 16, which means I'm trying to find what number, if I multiply it together 4 times, gives me 16. If I don't want to think about how that's going to work out, just type it in your calculator, right? 16, go up into your exponent with that little up arrow. Okay, let's try it. Let's try it without putting this the parenthesis around it. So 1/4. Enter. Okay, so on the 84, you don't have to put parentheses around it. It doesn't hurt it if you do, though. So the 16 to the 1/4 power, the answer would just be 2, right? Because what does that mean? That means what number times itself 4 times gives you 16, and that number would be 2, right? 2 times 2 is 4, times 2 is 8, 8 times 2 is 16. So that's why 2 would be the answer to that. Okay, but again, that's why we have a calculator also. Okay, let's look at number 3. Okay, we're in 10.2 right now on number 3. We have 1,296 to the 1/4 power, right? I don't want to try and just test that. I don't want to try and figure out what number times itself 4 times gives me 1296. So I'm just going to type it in my calculator. 1296. Go up into my exponent. My exponent is 1/4 again. So 1/4. And that number would be 6. All right, let's look at number 4. So I'm raising 49/81 to the 1/2 power. So I'm going to do this in my calculator in just a second. But remember, what does raising to the 1/2 power mean you're doing? You're taking the square root of whatever you're raising to that 1/2 power. Okay, so the square root means, and remember, even if it's a fraction, I just kind of treat them as 2 separate. So what was the square root of 49? 7. Square root of 81 is 9. Okay, if I did this in my calculator, let's put parentheses around that just like they did. So open parenthesis, 49/81. And close it. Now go up into your exponent. My exponent was 1/2, so 1 divided by 2. So now it's gonna give me a decimal. But remember, what do you do with that decimal? You just math, enter that. to turn it to your fraction of 7/9. Okay, but if it's to the 1/2 power, then you're just doing square roots, right? Which means you could have just looked in your list for those numbers. All right, let's look at number 5. Negative 243 in parentheses to the 1/5. All right, I'm just type that in my calculator. Now remember, square roots of negative numbers gives me a not real answer. Okay, the rule is if you're taking a root of a negative, then the root that you're taking, which in this case is the 5th root, needs to be odd in order to get an answer. Okay, if it's even, that means you're going to get a not real solution. Okay, so since this one is odd, I'm going to go ahead, I'll just put it in my calculator. My calculator would tell me not real anyway if it's not real. Okay, so in parentheses, negative 243, close. Go up into your exponent, and your exponent is 1/5. So 1/5, enter. Negative 3. So just like I was talking about on the last one, this is number 6. You have negative 16 in parentheses to the 1/2 power. In other words, you're taking the square root of this negative 16. What is that going to give you? Even if you put it in your calculator, it's going to tell you not a real number, right? Because if you're type in negative 16 in parentheses, raise it to the 1/2. So go up into your exponent, 1 divided by 2, right? It'll tell you not real. All right, on number 17, it doesn't want you to find the answer. It doesn't say to evaluate it or simplify it. It just says write the following as a radical. So remember how I did at the very beginning, and I showed you that the square root of 9 and 9 to the 1/2 power mean the same thing. Well, this says 17 to the 1/2 power, and it wants you to write that as a radical. Radicals are those symbols. Okay, so remember, what does 1/2 power mean you're doing? It just means you're taking the square root. Okay, number 8, you have 7 to the 5/8 power. Okay, so all the ones that we've seen so far have had 1s as their numerators of their exponents. This one's different. Okay, this number always tells me what root I am taking. So that's the number that you're going to put in the little area right there, whatever the bottom number of your exponent is. So what am I taking the 8th root of? I'm taking the 8th root of 7. Then this number is actually what you are raising, what's underneath there, to. So if this number is in, and see, that's why when it's a 1, I haven't even been talking about it, because what is it if you raise this at 17 to a 1? It's still 17. It doesn't affect it. Okay, but if I raise this here, oh, it looks like, you know what, on your answer too, it wants you to put the 8th root of 7 in parentheses. And then that out there. It doesn't matter, but just to be safe, put your 8th root of 7 in parentheses with your 5th power out there. Okay, last one of 10.2. It says simplify by first converting to a rational exponent. I'm actually not even going to do that. This right here, when you are taking, this is something new, right? I'm taking the square root of something with an exponent. Here's your shortcut. Whatever root you're taking, which is the second root when it's a square root, if you're taking that of an exponent, the shortcut is you divide your exponent by whatever root you're taking. So the square root of w to the 48 is w to the 24th. You can just divide your exponent by whatever root you're taking. Okay, so I'm going to do another couple of these because we will need some practice on that for this last section. Okay, so that was the end of 10.2, but I'm going to give you a couple more. Just to go over that shortcut rule again. Again, square root just means you divide your exponent by 2, so that would just give you x to the 6th. I use the same rule no matter what the root is. This number is what you divide your exponents by. So if I divided that exponent by 3 this time, I would have y to the 5th. So you're just going to divide your exponent by whatever root you are taking. All right, 10.3. There's 11 in this section. When you're taking the square root of a fraction, just like what we were doing earlier. Remember, it just kind of said to treat them separately. Okay, so when we get to this section, let's go ahead and write these separately. Okay, because these numbers right here, that's just like taking the square root of 100 and the square root of 121. If you're taking the square root of the fraction, you're taking the square root of the top and the bottom. So let's see, the square root of 100 was 10. The square root of 121 is 11. So you just would have 10 11ths. So let's use this rule when we get to number 2. You have the square root of 3 25ths. So let's write them separately, just like I did up here. I can't do anything with this, right? So because 3 was not in my perfect square list. So that means I'm not taking the square root of 3, so it's still going to have a square root around it. The only one that is the perfect square is this 25, right? The square root of 25 does turn to plain 5. So this top one, once I separated them, I noticed that I could take the square root of the bottom, so I did that. I just couldn't do anything with the top, so I just brought it over. So that's why you want to separate them, because sometimes you'll be able to do both of them. But sometimes you won't be able to do both of them. You'll just be able to do one of them. So you want to separate them so you can simplify the ones that do simplify for you. Okay, same thing on number 3. You have the square root of k over 4. So I definitely want to separate these, right? Because I see that I can simplify that bottom. So I'm going to have the square root of k over the square root of 4. I notice that I can simplify the bottom, right? Because the square root of 4 is 2. But I can't do anything with the top. So I'm just going to leave it as the square root of k. So it still has the radical symbol around it. Okay, let's look at number 4. The square root of w to the 6th over 36. So let's separate it again. Square root of w to the 6 over the square root of 36. Right? The square root of 36 is just 6, right? But this time I can do the top. I can also do the top because what's the rule? What is the shortcut rule when you're taking the square root of something that has an exponent? You just want to divide that exponent by 2. So the square root of w to the 6th is w to the 3rd. I can do that top one. So sometimes you can do the top and sometimes you can't. That's why you separate them. Okay. Starting with number 5 through the end. It still says express the radical in its simplified form, but this time I have the square root of 12. So what is different about a 12 than the other numbers that we've been doing? 12 is not a perfect square, like 25 and 16 and 9 and all those numbers in that list from the very beginning, okay? But I can still simplify this, okay? It's not going to want a decimal answer from putting it in your calculator. When you simplify this, you're going to break it into 2 square roots that are multiplied together. The 2 numbers have to do 2 things. They have to multiply to 12. So let's write the ways to multiply to 12. And the number times 1 we don't ever use. So all the other ways to multiply to 12. What I'm looking for in this list is any number that is a perfect square, a number that I can take the square root of. So let's see, the square root of 6 is not going to give me a whole number. Neither is the square root of 2, right? If you put either one of those in your calculator and took the square root of it, it's going to give you a decimal. But what about the square root of 4? That is a perfect square, isn't it? Yeah. So what you do is the first square root, when you break this up, that's where your perfect square is going to go. So the perfect square factor of 12 would be 4. 4 times what is 12? Because remember, these two numbers have to multiply to 12. 4 times 3 is 12. This over here is just kind of what's left over after you took the perfect square out of there. So once you break it up to its perfect square and leftover, then you take the square root of the perfect square. That's why you put it there, so that you could simplify it. So the square root of 4 is plain 2. This one over here is always just going to come down. It's kind of like it's the trash. It's just left over after you took the perfect square out, which means it just comes down. So the square root of 12 simplified is 2 square root 3. So again, if it's not a perfect square, find the numbers that you can multiply to get this number and look for a perfect square. Once you find it, that perfect square comes in your first square root. Its pair just goes in the other one. Take the square root of that perfect square and then just drop down the other part. Okay, that's what we're going to do for the rest of the time. Let's look at number 6. Negative, but it's on the outside, square root of 20. Okay, what does a negative on the outside always do? It just comes down. $20 is not a perfect square, so I'm going to break it up. Let's see, 20 times 1, but remember, we don't ever use that. 10 times 2, 5 times 4. Those are the ways to multiply to get 20. So, not a perfect square, not a perfect square, not a perfect square, but a perfect square, right? It's 4 again, right? Sometimes people say, well, 10's a perfect square, but it's not, right? 10, we use 10 a lot in math. We like to use 10s because they're easier for us, but it's not a perfect square, right? If you take the square root of 10, you're going to get 3 point something, 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 something. Okay, 4 is the only one in the list that we're going to use. So it doesn't matter where it is in the list. If you're the perfect square part, you always come first. 4 times 5 is 20. So remember, 5 is just what's left over. My negative is just going to come down again. The square root of 4, I put it in the front because it's my perfect square. So the square root of 4 is 2. Then drop down the square root of 5. Number 7. Negative on the outside again. Square root of 54. Negative just comes down. 54 is not a perfect square. So let's see, 54 and 1, but we're not going to use it. Now, if you aren't interested in finding all the ways to multiply to get 54, remember, we've done this before. To find the ways to multiply to get a number, we did this when we were factoring. We would just go to our y equals, clear it out. Type in whatever number you're trying to find the ways to multiply to get, which in this case is 54, and then divide it by x. I'm just trying to find the numbers that multiply to get 54. I don't even need that second row that I put when I'm factoring because I don't need to see what the numbers add to, right? That's just when we were factoring. If you're just trying to find the ways to multiply to get 54, just put in 54 divided by x, then go to your table, second table. Okay, I would start at 0 down here. And you just want the positives. So there's my 1 and 54, right? I already got that. If there's not a decimal, that means that's how you multiply to get it. So 2 and 27. So let's keep going to see if there's more. Not a decimal, though. 18 and 3. That one's a decimal, which means 4 doesn't go into 54 evenly. So I'll just keep going. Neither does 5. Oh, but there's one. 9 and 6. And I would keep going, but why? Oh, and then if it flip-flops, that means you're done, right? 9 and 6 right there again. So let's see. Here's my list. Which one of those numbers is a perfect square? What number can I take the square root of and get a whole number answer? That one, right? That's the one. That's why you want to keep that perfect squares list that I gave you at the beginning handy. Because once you make this list, then you're just looking for actually the highest one of those numbers that are in this list. The only number in that list that's in this group is 9. So 9 is my perfect square. It'll go in the front. 9, its pair is 6, so 6 is in the trash. And then just bring this negative down. That's my perfect square, so that's the one I take the square root of. The square root of 9 is 3. Drop down the square root of 6. Okay, let's look at number 8. Square root of 85. Let's see. I don't know. Let's just go to our y equals and type in 85 divided by x. And go to my table. I would start at 0 or 1, I guess. So 85 and 1. Looking for numbers that aren't decimals. So this one, 17 and 5. And there's 17 and 5 again. So if you see, and again, that means you're done. You don't need to go any farther. So here's my list. And it says to simplify this radical. But if I'm looking, remember, we don't use that. So my only options are 17 or 5. Are either one of those numbers a perfect square? If you take the square root of 17, you're going to get 4 point something. If you take the square root of 5, you're going to get 2 point something. So neither one of those are perfect squares, which just means this radical cannot be simplified. So you would check the B, cannot be simplified. Right, number 9. The square root of 27t squared. Okay, so 27 is not a perfect square. So let's see, 27 times 1. And the only other way to get it is 9 times 3. Not counting this. There's my perfect square. So I can simplify this. If you have a perfect square, you can simplify. So let's break it apart. 9 is my perfect square. 9 times 3 is 27. Now remember what you're creating right here. You are creating a radical that you will be able to take the square root of. So I've got to decide where to put the t squared. Remember what the shortcut is when you're taking a square root of an exponent. You want to be able to divide it by 2 evenly. If you can divide this number by 2, then all of it needs to come in your perfect square. And I can't divide 2 by 2. So let's see. All of t squared comes over here. So I just created a perfect square that I can now simplify, right? The square root of 9 is 3. The shortcut is to divide my exponent by 2, which is just going to give me t to the first, which is just t, right? If you divide that exponent by 2, you get a 1. So the square root of 9t squared was just 3t. And what do you always do with whatever's over here? You bring down exactly what it is. Right? 2 more. The square root of 144, x to the 3rd, y to the 7th. Now, 144 is a perfect square, right? It is in that list. The square root of 144 is 12. So I almost don't even need to break this up. It's just that these are not perfect squares. Right? I can't divide my exponents by 2. That's what's telling me I got to break this apart. It's just that I put all of 144 in my perfect square because it is a perfect square. I don't need to break that up. Now, what am I going to do with these x's and y's? I can't divide this one by 2 evenly. So here's what you're going to do, because you want to put as much of it as you can over here in your perfect square. This radical is simply just saved for whatever is left over after you put all your perfect square up front. So if you can't divide your exponent by 2, what kind of numbers divide evenly by 2? Even numbers, right? All even numbers. Odd numbers don't divide by 2. So if your number is odd, you're actually just going to put the even number right below it in your perfect square, which leaves you left over with the x, right? X squared times x does give you x to the third. So again, if you want your exponent to be divided by 2, it just needs to be even. So if it's odd, just put the even number right underneath it here and put your x in the trash. So same thing with the y. This one's odd, which means I can't divide it by 2. So just go right below it. So y to the 6th and put your leftover y in the trash. See, I can now take the square root of this. The square root of 144 is 12. So now I can divide my exponents by 2. So this one will just be x. If I divide this exponent by 2, I get y to the third. And then just drop down your trash like you always do. It just comes down, square root of x, y. Last one. Now, why couldn't I just took the square root of that one? The x and the y are what messed it up because I couldn't divide them evenly by 2. That told me I needed to put some of those in the trash. But look at number 11. You have the square root of 100 x to the 6th. 100 is a perfect square. And I can divide my exponent by 2. So this is just one that I don't need to break apart. There's no reason to break it apart. It is all a perfect square, right? The square root of 100 is 10. You divide your exponent by 2, you get x to the third. So you didn't need to break that one apart because I could take the square root of it exactly how it was written. So just 10x to the third. So that is all of 10.1, 10.2, and 10.3. So we are done with everything we are going to cover for the semester, which means Tuesday and Thursday of next week, because there's not even a test covering these last sections that we went over. So we don't need to review for a test, but next week on Tuesday and Thursday, we are going to be reviewing for the final exam. So let me write this, the end of the semester schedule, what's happening here. Get my calendar up. So today, we did 10.1, 10.2, and 10.3. Tuesday of next week will be the 27th. Thursday will be the 29th. Both of those days we're going to review for the final exam. Okay, so the next week, there is not that Tuesday of the next week, which is May 4th. We don't technically have class. It's called the Student Study Day for all classes. Okay, I will Zoom live for anybody that just wanted to check in with me. If they had any, I'll just have a live Zoom going. I'm not going to cover anything, but if anybody had any questions about anything at all, I will be live. I just won't be taping it because we're not going to cover anything new. So that's what I will do this day. I'll just be live, but not going over anything. Your final exam opens on Wednesday, May 5th. It is in Math Lab, just like any of your other assignments, okay? You'll just see it where you see the rest of your assignments. Your final exam will be available on Wednesday, May 5th, because that's the first day of the finals. And then on Sunday, May 9th, your final exam is due. Okay, so I made it due on Sunday just so it would be just like every other week for the whole entire semester, right? All your due dates are Sundays. So it'll open on the Wednesday morning. It'll be due that Sunday at midnight. It's going to be 25 questions, multiple choice. And these 2 days, we are going to go over exactly what you need to be looking at. Okay, all right. Does anybody have any questions about that?